I see two of them. So I see the integral from 0 to 1 of x dx plus the integral from 0 to 1 of square root of 1 minus x squared dx. Well, the first one's pretty easy. What's that? This is just a what? It's a triangle? Yeah, it is a triangle, isn't it? Yeah. So it's a triangle with base. Yeah. Yeah. No, that's it. This is a triangle with a base of what? And a height of? Yeah, so what's the area of this? This is a triangle. It's going to be equal to 1/2. Okay. So this one right here, this is the stumbling block, the square root of 1 minus x squared. U-substitution doesn't work because there's no x on the outside to cancel out. It doesn't work. But what shape is that? What is y equals the square root of 1 minus x squared? What is it? Use words. It's a half circle. It's a half circle with radius what? This is a half circle with radius 1. Half 0. Oh, 0 to 1. Yes. Ah, it's a quarter circle. Thank you. Good catch. Quarter circle with radius what? So the area of a circle is what? Pi r squared over, and this is a quarter, so it's over 4. So what's the answer to this? 1/2 plus pi over 4, and you're done. That's what it means by interpreted as the area of shapes. That's what it means, because you can't do this with straight integration. You right now don't have a way of integrating the square root of 1 minus x squared. For example, it's related to, not for example, it is related to the fact that, can you prove to me that the area of a circle is pi r squared? It's kind of a given, because my teacher told me years ago, right? But here's the thing, literally, do you know how it's proven? But the idea is this: if you have a circle right here, if you have a circle radius r, you can estimate the area by filling it full of identical triangles, right? And then as you make more and more triangles, the estimated sum gets really close, right? So as you break it up into n triangles, you can theoretically, it should come out to be pi r squared, right? It's a little tough, but you can do it. It's not that bad. Can you try to compute an integral on this using U-substitution? You can, right? But what happens? What happens when you try to evaluate this, Fawn and Tina?
You get.
What do you get?
You get the natural log of 96 minus the natural log of -3.
Yeah. Can you take the natural log of -3?
No.
No. So at that point, there are 3 things you have to consider. 1, did you make an algebra mistake? You'll check your work, and you know what? You didn't make an algebra mistake. 2, did you copy down the problem wrong? But then the third one is, does this actually have an answer? And it doesn't. And you can recognize it at the beginning if you think about something first. What's the domain of this function? All real numbers except 2 and -2. But what are you integrating across? From 1 to 10. You are integrating across a vertical asymptote. You are attempting to integrate across a what? I can almost spell here. Okay, so on this one, what method are we going to use, do you think? Yeah, what's the big sign that we're going to use U-substitution?
The power of the denominator is the derivative of the...
Yeah, there's a good relationship between the power of the numerator and the denominator, right? And that's, the top is 1 less than the bottom. So you know when you differentiate the bottom, you're going to have a cube in it, and that's what you're looking to cancel. So you're going to say u is equal to 1 plus x to the 4th, and you can tack that constant on because it's really helpful to do that, because when you take the derivative of a constant, you get
0.
Goes away. So du is equal to 4x cubed dx. So dx is equal to du over 4x cubed, and this substitutes really nicely. Get x cubed over u times du over 4x cubed. So what cancels? Hey, it's gone. So you end up with 1/4 the integral of u to the -1 du. What's the integral of u to the -1? 1/4 ln u plus c. What is u? 1 plus x to the 4th plus c. So it works out really nicely. You'll get good at recognizing it. Absolutely. What do you evaluate to find the displacement? The what? Of what? Of what?
Velocity.
Yeah. So that right there is equal to the displacement. And what does that come out to be? 175 over 6?
Yes.
Okay, so what about the distance traveled? What do you have to evaluate? You do the integral from 0 to 5 of what? Ah, If you had your calculator, can you do this on your calculator as well?
Yes.
Yeah. That right there is distance traveled. What does that equal?
That's equal to 185 over 6.
185 over 6. So if the distance traveled is more than the displacement, what do you know for certain about that particle?
Change direction.
It must change direction at least
Once.
once. Has to change direction at least once.